All right. Hi, guys. I'm sorry I'm not there. I truly miss seeing you. So I hope you've had a good day. This is just going to be a short little video to review a few things before you do some book work. Okay? So hopefully you guys understood that the lesson 77 worksheet that you took out of your notebooks, out of your workbooks, you have all week to complete. And so then you'll turn them in next Tuesday to me. And then because I'm not there, because I couldn't go to the school building, you have the treat of not having your daily multiplication quizzes right now. So enjoy that treat, but keep studying them. All right. Sorry, I can't show my face. I can't turn the camera. All right, here we go. So just reviewing. Remember factors. Factors are numbers that multiply together to make a product. So here we have the number 24. So what are the factors of 24? That means what multiplies together to make 24. So we have 1 times 24, 2 times 12, 3 times 8, 4 times 6. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24, right? Those are the factors. These are numbers that can be multiplied together to get the product 24. So factors are used when we need to reduce. All right, reduce means we're keeping things equivalent. If I eat 2/4 of a pizza, it means if I reduce it, I ate 1/2 of the pizza, right? So we're reducing. All right, then last week we started introducing multiples. Multiples are essentially the multiplication tables of a number. These are all the multiplication tables of whatever number you're given. So, for example, the number 3, the multiples of the number 3, 3, 6, 9, 12, 15, 18, 21, 24, 27, and so on and so on and so on. It can go on for infinity. Those are the multiples. And we use multiples when we need to start finding your common denominators. Because remember, we can't add or subtract fractions if the denominator, where's the denominator? Is it the top or the bottom? That's right, it's the bottom number. So we can't add or subtract fractions if that bottom number, if they're not the same, because we need them to be the same size pieces before we can be adding or subtracting them. So that's where we use multiples. Okay, so here, what if I give you the numbers 3, 8, and 12? And I want to know what is their least common multiple. That means when you go through the multiplication tables of 3, when you go through the multiplications of 8, and when you go through the multiplications of 12, what is the first multiplication table they have in common? Their first multiple. That's that least common multiple. So here we have, I just did through 12, the multiplication tables of 3, right? 3 times 1, 3 times 2, 3 times 3, 3 times 4. Remember, the number 1 is never a multiple unless it's 1 times 1. But otherwise, multiples are always 3 times 1 would be 3. 8 times 1. So the multiples of 8 start at 8. The multiples of 12 start at 12. So here I wrote the multiplication tables of 3 up to 12, up to 3 times 12. The multiplication tables of 8 up to 8 times 12. And the multiplications of 12 up to 12 times 12. So when we look through, you guys probably have figured it out by now. The first multiplication table they have in common is 24. 24, 24, and 24. So that's the least common multiple. Now, if we kept multiplying out, they would have other things in common, but we want the least common. So that is the first multiplication table we get to that they all have in common. Least common multiples. Factors are the digits that multiply together to make a number. Multiples are the multiplication tables. All right, so now let's talk about equivalent. Remember, equivalent means equal, right? So 3/4, that's what we say. We have to say 4 goes into 12 how many times? Or essentially, what was 4 multiplied by to make 12? That's right, it was 3, right? So we have times 3. But what you do to one, you do to the other. You have to keep it equivalent. So times 3. So we can say 4 goes into 12 3 times. So 3 times 3 equals 9. So these are equivalent. I'm going to stop writing on it because it's getting blurry. There we go. So it's equivalent. 3/4 is the same thing as 9/12. If I have a cookie cake and it is divided into 4 equal pieces and I eat 3 of them, I've eaten a lot of cookie cake and I have eaten 3/4 of it. But if I have that same cookie cake and before I eat it, instead of cutting it into fourths, I actually cut it into 12ths, which means it's 12 smaller pieces, and I eat 9 of those pieces, I've eaten the same amount of cookie cake as if I had eaten 3/4. All right, so same thing, equivalent. 7/8 is the same thing. 7/8 equals how many 16ths? So we say 8 goes into 16 how many times? 2. So 2 times 7 is 14, right? 14. So 8 was multiplied by 2. We keep it equivalent. 7 is multiplied by 2. We keep it equal. So 7/8 is the same thing. 7/8 equals 14 over 16. But it also works in reverse with simplifying. If you see here, 4 and 2. So what did they reduce it to? You can do it backwards and say 2 goes into 4 2 times. So, or just say it was 4 divided by 2 equals 2. 2 divided by 2 equals 1. They found the common factor, right? The greatest common factor between 2 and 4 is 2. So here, 8/12, it is the same thing as, now again, you can do it in reverse. What is 12? What is 12 divided by 3? That's 4. So we would do the same thing. 12 was divided by 4 to get 3. 12 divided by 4 will give us 2, right? And 4 is their greatest common factor. If I write the factors of 4, 1, if I write the factors of 8, 1, 2, 4, and 8, and I write the factors of 12, what multiplies together to make 12? 1, 2, 3, 4, 6, and 12. The biggest number they have in common is 4. So we divide both. We keep it equal. We divide 8 by 4, we get 2. 12 divided by 4, we get 3. So when we raise them up and when we reduce them down, we're keeping it equivalent, okay? So hopefully that was a good review. You guys are going to go through lesson 78 in your books. Please work hard. Please stay on task. Help each other out. And enjoy going through lesson 78. Okay, bye guys.